Hello viewers, welcome to Senior College Mathematics. Topic of discussion is probability. Lesson 6, multiplication rule of probability. In this session, we shall consider independent and dependent events. We start with the first concept, independent events. If two events, A and B, can occur without affecting each other, then the two events, A and B, are said to be independent events. Take, for example, you are throwing two dice together. Now, the probability of 2 showing and 3 showing are independent. That of 2 showing will not prevent, it will not affect that of 3 showing. So, the event of getting 2 and 3 are independent. But if you are throwing just one die, the probability of getting 2 and 3 are dependent because it is one die. If you throw it once, you can only obtain 2. Maybe when you throw it again, 3 can come up. The probability of 2 or more independent events is found by multiplying the individual probability of each of the events that are involved. To identify independent events, words like and, both, and or are used. In addition rule, we have or, either, and neither that help us to identify addition rule. But for multiplication rule, and, both, or help us to identify the rule. Mathematically, probability of event A and B is equal to probability of event A intersection event B, and it is equal to the product of the probabilities of the two events. The second concept is dependent events. Two events, A and B, are said to be dependent if the occurrence of event A affects the occurrence of event B. Take for instance, you are throwing one die and you need 2 and 3. Because you are throwing one die, the probability of getting a 2 will prevent 3 from showing up. So the two events are dependent. When 2 shows up, 3 will not. And when 3 shows up, 2 will not. Mathematically, probability of event A and event B, which are dependent, is equal to probability of event A intersection event B, and is equal to probability of event A times probability of event B slash event A. The probability of event B slash event A is read as probability of B given that A has occurred. So this term is read as probability of event B given that event A has occurred. Problems in probability can involve selecting, choosing, picking and taking more than one object in a problem. This leads to when probability is multiplied or added. Some other conditions imposed on probability problems which should be noted when solving problems on probability are picking or drawing with replacement. This is the situation where the object picked or drawn is put back after a condition before another is picked or drawn. You always replace it if you have the condition of with replacement. In this case, the total number of objects remain the same before the next object is drawn. We also have picking or drawing without replacement. This is when the object picked or drawn is not replaced, is not put back before subsequent pickings or drawings are carried out. In this case, there is reduction in the number of the affected objects and that of the total. The next condition is take away. This is the same as picking or drawing without replacement. Note, if a problem did not specify that the object is replaced after picking, then it should be taken that there was no replacement. As a matter of fact, the default is without replacement unless it is specified that replacement was done. Else, the default is without replacement. In other words, if the question gives no condition at all, we take it that replacement was not done. Examples 26. A box contains identical balls of which 12 are red, 16 white, and 8 blue. 3 balls are drawn from the box one after the other without replacement. Find the probability that A, the 3 balls are red, B, the first is blue and the 2 are red, C, 2 are white and 1 is blue. Solution. Note that any condition must include 3 objects. From here, 3 balls are drawn. Since 3 balls are drawn, drawing is without replacement, which shows dependent event. So let arrow be equal to red balls, and they are 12 in number. W, white balls, they are 16. B, blue balls, they are 8. Total balls in the box is equal to 36. That is 12 plus 16, 28 plus 8. You have 36 balls. A part of the question, 3 balls are drawn, their probability. That is probability arrow 1 times arrow 2 times arrow 3. You have it in this form. Remember, without replacement indicate dependent event, written as probability the first ball is red times probability the second ball is red, given that the first is red times probability the third is red, given that the second and first are red. So without replacement, the total is affected. Now let's come here. The first is red. You have 12 red balls over total 36. Without replacement, that means the red balls are now 11 and the total is 35 times 11 over 35. Before the third drawing, you are left with 10 red balls and 34 in total. That is 10 over 34. When you multiply and simplify, you have 11 over 375. B. First ball is blue and the two red. That is the next probability. That is probability blue and red. The first is blue times the second is red times the third is red, written as probability blue times probability red, given that the first is blue times probability red again, given that the first is blue and the second is red. So number of blue balls, they are 8 over total 36. The second one is red. So at that point, the red balls are not affected, but the total is affected because you have picked the first ball as blue before the second as red. So red is 12 over total 935. The third drawing is also red. Remember, the second here is red. So at the third drawing, number of red balls are now 11 and the total becomes 34. When you simplify and multiply, you have 44 over 1785. C part of the question, you are to get probability 2 are white and 1 is blue. That is probability, the first is white, W1, the second is white, W2, and the third is blue, written in this form and in this form showing dependency. So the first drawing is white. At that point, the number of white balls are 16 and the total is 36. The next drawing is also white ball. So the white ball are now 15 because without replacement, and the total now 35 times the third drawing is blue ball. At that point, the blue balls are 8 and the total now 34. You have picked 2 white balls without replacement. The total becomes 34, then you have 8. That is 8 over 34. When you simplify and multiply, you have 16 over 357. Example 27. A class consists of 30 boys and 20 girls. 60% of the boys and 40% of the girls can swim. A boy and a girl are chosen at random. Find the probability that both can swim. We need to get the number of boys and girls that can swim before we can obtain the required probability. Solution: boys who can swim are 60% of the boys in the class. That is 30 boys. You have 60 over 100 times 30, that is 18. 18 boys can swim. Girls who can swim are 40% of the girls in the class, that is 20. You have 40 over 100 times 20, that is 8. 8 girls can swim. Now let's get probability of boys who can swim. That is 18 boys over total boys in the class. That is 5 over 3 over 5. Probability of girls who can swim is equal to number of girls who can swim, 8 over total girls in the class, 20, and that reduces to 2 over 5. Now probability both can swim. Both indicates multiplication rule. So you have probability of boys who can swim times probability of girls who can swim. That is 3 over 5 times 2 over 5, and that is 6 over 25. Example 28. A bag contains 3 black balls, 4 white balls, and 5 red balls. 3 balls are removed without replacement. What is the probability of? Now figure 1, 1 of each color. Now figure 2, at least 2 red. Solution: let B be equal to black balls, they are 3 in numbers. W equal to white balls, they are 4. Arrow equal to red balls, they are 5. Total balls in the bag, they are 12. That is 3 plus 4, 7 plus 5. You have 12. The first part of the question, 1 of each color means different colors. That is, you have black, you have white, you have red. So you have to consider the possible arrangements. You can have black, white, red, or black, red, white, or white, black, red, or white, red, black, or red, white, black, or red, black, white. So you have these possibilities. So probability 1 of each color is equal to the probabilities of the various possibilities, the possible arrangement. Remember, without replacement. So the first one, black there, is 3 over total 12 times white is 4. The total is 9, 11 because you have picked black earlier, times red 5 over 10. The first one is this, the second is this, the third is this, you have the fourth, the fifth, and the last one. If you simplify each of the brackets, you have 1 over 22 plus 1 over 22, and so on. You have like fractions. If you add the numerators, you have 6 over 22, which reduces to 3 over 11. Remember figure 2 of the same question, probability at least 2 red. At least 2 red means where you have 2 reds and 3 red balls. This includes all possibilities that have 2 or 3 red. That is arrow, arrow, W, or arrow, W, arrow, or W, arrow, arrow. Then you come again, arrow, arrow, B, that is red, red, and black, or red, black, red, or black, red, red. You move to red, red, red. So we have these possibilities. Therefore, the probability at least 2 red is the probability of the various possibilities. So the first one, red, is 5 over total 12. You are picking red again. Remember, without replacement, the number of red balls will be affected because you've kept one aside. It becomes 4 over 11. The next one is white, which are 4. So the 4 remain the same, but the total will become 10 because you have picked 2 red balls. For the second arrangement, you have this. For next, you have this. For next, you have this. For the next one, you have this, this, and this. If you simplify the first 3 brackets, you have 2 over 33 respectively. If you simplify the last 4 brackets, you have 1 over 22 respectively. So the first 3 fractions add up to 6 over 33 plus the last 4 fractions add up to 4 over 22. The LCM is 66. Divide it by 33, you have 2. 2 times 6 is 12. The same LCM, 66. Divide by 22, you have 3. 3 times 4 is also 12. When you add, you have 22 over 64, which reduces to 4 over 11. Example 29. A boy has 10 identical marbles in a container consisting of 6 red and 4 blue marbles. He draws 2 marbles at random, one after the other, from the container without replacement. Without replacement, find the probability that A, the first draw is red while the second is blue. B, both draws are of the same color. C, both draws are of different colors. Solution: let arrow be equal to red marbles, they are 6 in number. B equal to blue marbles, they are 4 in number. The total number of marbles in the container, they are 10. So let's get the required probabilities. Solution continues. The given condition without replacement shows dependency. That is dependent event. So probability first draw is red while second is blue. That is probability red times probability blue, given that the first is red. That is 6 over 10 times 4 over 9. Here is 9 because after picking the first ball red, the first marble red, it is not replaced. So the total is affected. So you have it in this form. When you multiply and simplify, you have 4 over 15. Then B, probability both draws are the same color. That is probability red and red, or probability blue and blue. You write it in this form. The first one is red. That is 6 over 10 times. The second one is red. You now have 5 over 9 because without replacement. Plus, you come here, the first is blue. You have 4 over 10 times. The second is blue, now 3 over 9. When you simplify, you have this result. If you find the LCM and simplify further, you have 7 over 15. See, probability, both draws are of different colors. That is, probability, you pick red before blue, or probability, you pick blue before red. Number of red, the first drawing, you have 6 over 10 times blue, 4 over 9, plus the second drawing, you start with blue first, that is 4 over 10 times the red, 6 over 9. When you simplify, you have this result, and 8 over 15. End of lesson 6. Thanks for following to the end. Don't forget, watch out for more from the voice of Peter Kos. If you are not saved, your life is in crisis, your life is in trouble. To avoid all of that, you have to give your life to the Lord Jesus Christ and confess him as your Lord and personal Savior every day of your life. If you are saved already, congratulations. Live righteously and be prepared, because on the last day, some will be taken and some will be led. Be good to yourself. Stay out of trouble. Study your books. Do the needful at all times. Flee every appearance of evil. Don't defraud others to make money. Find something good and genuine to do with your hands and your brain, and the Lord will bless you. Goodbye and stay tuned.